Okay, recap. Before we stop last lecture, we studied about degree of depolymerization, dP. We take the total moment, total molecule weight divided by individual molecule weight. Okay, so we take the total chain of molecule weight divided by individual monomer molecule weight. Then you get what is the degree of depolymerization. Okay, we have gone through example one, right? So recap with example number 2. So example number 2, you're assuming you're having all this information. So and this one you have a PVC, polyvinyl vinyl chloride PVC. So you need to compute number average molecule weight, and B, calculate the degree of polymerization. C, calculate the weight average of the molecule weight. So on the left, you have you're given the range of molecule weight. You have a few strain there, and then the X, the ratio, right? X is a fraction of total number of chain within the responding size range, right? So meaning if you add all these together, you get 1. Get all this, you get 0.5, 0.6, 0.22, 0.27, 0.2, 0.8, 0.2. All this you add up, you get 1. Okay, then the one on the right is the weight fraction of the molecule within the same size interval. So this is the molecule, the weight fraction. Okay, weight fraction also, if you add all together, you get 1. Okay, you get 0.2, 0.02, 0.1, 0.18. You add all together, you get 1. Okay, so the first, we calculate the number average of the molecule weight. So you break the number. So you take the range, then you copy the X number. You calculate the mean first. If you're given a range, you try to calculate the mean, the molecule weight range mean. Calculate mean, you take the minimum plus the maximum divided by 2. So the first one, you get 15,000 divided by 2, you get 7,500. So on. So you do the same for the rest. Then you get XIM, means you take the mean multiply by XI, you get the product of XM. So you get 7,500 multiplied by 0.05. Okay, you'll get 375, right? Okay, so once you get this number, you repeat the same procedure for the remaining range. Get the same procedure for remaining range. Then you get the total. You get the total number of XM. You take 375 plus 2,000 plus 3,850 and the rest. You get 21,150. Then the rest, you just use the equation to get the number average molecule weight. Okay. Okay, so number average molecule weight is the total of XMI. Okay, is a number average molecule weight. So this is the average molecule weight. Okay. Then you get the degree of depolymerization. So to get the degree of polymerization, you need to get the ratio between the total polymer, the total of your molecule weight. This is the total chain, the main chain, divided by the moment of your mer, of your individual cell or individual component. So you calculate the individual component for PVC. So PVC, the only difference from the ethylene is that you replace one of the hydrogen with chlorine, Cl. So this is the mer, or this is the monomer of the PVC. So what is the molecule of this one? Carbon, you know, is 12. Right? Hydrogen, you know, is 1. Chlorine, you need to refer to periodic table. Also, don't memorize that one. So you calculate, there are 2 carbon, 3 hydrogen, 1 chlorine, and then refer to periodic table. Periodic table, Cl will tell you is 35 gram. H is 1, carbon is 12. So you do the maths, right? You press the calculator, you get a total molecule weight for the monomer. You get 62, right? So one unit is 62. Then you get a average molecule weight here. So you take this one divided by this one, you get degree of polymerization. Okay, right? You take this one divided by this one, you get the dP, degree of depolymerization, or how many unit of monomer you have. Okay. Okay. So dP is, if you do the calculation, you'll get 338. Okay, get 338. Of course, you'll get like decimal place or something. Get the round number. Okay, get the round number. Even though, let's say you get 338.78, you still use 338 because 0.78, that one do not complete. It's not a complete polymer, so we don't count. Okay. Right. So take note on that. Even you get more than 0.5, you still what PVC unit is CCHHHCl, right? Of course, if this one come out from for your test 2 or final exam, I will give you the unit. So how you differentiate the section A and section C? Section A, you use Xi. Section C, you use weight fraction, W, Wi. If the weight fraction one is to try to get the weight average. If you see the Xi, X is a number of fraction, then you calculate for number average molecule. Right. So that is the keyword lah. It's a keyword what you are going to calculate. Okay. Right. So don't confuse number average and weight average. Number average, you will see Xi, small xi. If you calculate the weight average, you will see Wi. Okay. Okay. So then today we'll try to conclude chapter 10. No, chapter 10, polymer. Then after the break, then we have time, then we go into composite. Okay. We have ceramic. Okay. So next we look at what is the function of that individual cell or monomer. Okay. So in order for the individual monomer to form a chain of reaction, you at least need two active chemical bond. So number of active bond, chemically, we use functionality. Okay, the word functionality means number of active bonds that create the chain, the long chain. Okay. So if you have monomer that have two active bonds, then you have bifunctional. The chain, the long chain, is called bifunctional. Means you have two active site or two active bonds. Bi means two. Plus means two. Okay, ethylene. How you know ethylene is a bifunction? So you have a two active zone here. Let's say carbon. You cannot break hydrogen, right? Hydrogen already mixed with one. So carbon, if you want to break double bond, a double covalent bond, you break, you get two active electron on each side of the carbon. So that one you get bifunction monomer. Okay. Okay. Then you have 3-1 means you have triple bond. Then you get 3 lah. For example, phenol C6H5OH. If you're given a chemical reaction, a chemical formula C6H5OH. Are you able to draw the crystal chemical structure? What do you do? I will do the carbon first. I have 6 carbon. I have 6 carbon. 1, 2, 3, 4. I have 6 carbon, 5 hydrogen. So I will draw the C first. 1, 2, 3, 4, 5. I will spare 1 somewhere, but I will just draw 1, 2, 3, 4, 5, 6. So I know that each carbon I have 4 free electron. Then I have 5 hydrogen. Hydrogen is 1, right? Hydrogen have 1 active electron outside. So H here, I complete 1. So then I also combine H here, get 1. Right? So I can combine another H here if I want. So this one become 1. Then this one also I contribute another 1. This one I contribute another 1. But if I form like that, how about the rest? Right? How about the rest? So here I can. So here, I still have a lot of space here. So you need to rearrange. OH is 1 negative. Right? OH is 1 negative. So if you form like that, this is OH. Then you still have lots of space to fill in. You know that carbon and carbon, they can form double bond, triple bond. So you try to rearrange, put inside, and then you try to break, and then you combine. Right, you break this one out, you put this one in, become double C or triple C. Try to complete the molecule. It will take some time to rearrange the structure, but you should able to do it. So again, there is a shortcut to reduce all the lines in the crystal structure with a ring, something like this. Okay, so earlier I give you one table that show you the ring. So if you see this one, it means that you have a carbon and hydrogen in this shape, and then with one OH. So later I'll show you the table. when you have time. I think I have one table for that. Okay, so at this moment, we don't care about how to draw this one. Just that you can just need to bear in mind that you should able to draw the chemical structure, right? Right. So this is a hydrocarbon structure. So you have carbon and hydrogen that bond with them. All right. So if you have a large scale, then you have a non-crystalline. Okay. The word crystalline you did learn in the earlier chapter. Crystalline means it is a repeated pattern that you can observe. So if you see polymer something like this very messy, then it's a non-crystalline. Okay. Okay. Then we already done with the polymer CH formula, and then CH when you have hydrocarbon again, general CH formula CnH 2n plus 2 is a hydrocarbon general formula. Okay. Then we look at PVC or Willi polymer. Willi polymer, what I mean by Willi means that you will have only one hydrogen of ethylene replaced with another atom of the group atoms. So this is called Willi polymer. So for example, general reaction of polymerization to get the PVC, or not PVC, but it's a PV something like Willi polymer. For example, you look at this one. So this is a monomer. And again, what is the number n? N is the degree of polymerization, dp, right, or number of polymer that you have. So you replace the one of the hydrogen with one of the element R here. Okay, so it will form this one, double bond, carbon, double bond, will break into single bond. So this one will become active site. Okay, become active site. So just now we learned one technical word is what's the technical word? What's the technical word just now? If we have two active site, it's a bi what? Bifunctional. So it become bifunctional polymer. Yeah. Okay, so this is a general equation when you form Willi polymers. Okay. So you have lots of Willi polymers. So this is you don't need to memorize. You only need that you know that what is Willi polymer definition means that you replace one of the H with something else. So for example, polyethylene is a C and H things. So you don't have added anything other than hydrogen. So this is not really polymer. This is a normal hydrocarbon polymer. But when you replace with Cl, it becomes PVC. We replace CH3, it becomes polypropylene. You replace with the ring, it become other things. You replace with H with this one, then it become one thing. You replace this one, it become another thing. The main idea here is that you take the ethylene structure, you replace one of the H with other things, it becomes really polymer. That is the main concept. Okay. So this one I show you just now. So what happens if both hydrogen will change? Just now, ethylene, you have 4H, but when you replace one of the H, it becomes Willi polymer. If you replace two, it becomes another name lah, Willidine polymer. So again, I won't ask you this one in your assessment. All right, you just need to know that when you change something in there, that we are given them differently. Okay. So this is another crystal structure of Willindine polymer. So means you change the 2H with two other different element other than hydrogen. So in this case, you have 2Cl. This one you change with ClH3 and C something. Then another two definition or two technical word. Homopolymer. Homo means same. Homopolymer means all the monomer you inside the chain is the same, or you can textbook say it is a single repeating unit. Okay, single repeating unit. Let's say you have one unit we label as A, so you have A, right? A long chain in the monomer. So copolymer means you have more than two different monomer inside. For example, you have all these different things. So here from A to A, B, C, D, you can see there's a different tone of color. Some dark color, some dark blue color, some very light blue color. So if you see that the first one is a random polymer, is a random distributed polymer. All right, but all these are called copolymer. You only have two kinds of polymer, homopolymer and copolymer. Okay, so one is random. There's the sequence that you cannot predict. You cannot like write in the equation or something. B is alternate regularly, so you can see alternate dark blue, sky blue, dark blue, sky blue, dark blue, sky blue. It's like A B A B A B A B sequence. Okay. C is a block copolymer. What I mean by block? It's like A, then B, 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 then A, B, 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 B. Okay, it's like a train container like that. Okay, then the D is a graph. Graph is like there's a chabang there. It's like you know, it's like got the chain outside. Okay, so in the body of A, then by the side of one of the A, you have a B come by the side of the polymer. So this one is called graph copolymer. Okay. So what area of assessment that this kind of this slide can come out is that we will ask you to define, explain what is homopolymer and copolymer. So if this kind of question come out, normally this one will be 1 mark with the diagram. You just draw circle, or you just blank lah. You just draw circle, 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 circle like that. You just need to draw like 5 or 6. This one, then you explain what is homopolymer. Then when you explain copolymer, you divide into these four types of copolymer. Then you draw lah. You don't need to draw a complete one. You just need to highlight the differences between the 4. Okay. Okay, so this is the random copolymer that I mentioned just now. Alternate and so on. A, B, A, B, B. Okay, this one I already explained. Okay. So this is how you explain. You can either draw graphical or can use alphabet to explain also can. Okay. This is another illustration that you can use. If you have a black pen or blue pen, then you can do the same. So random, alternate, block, and graph copolymer. Okay, then the next one is about chain reaction. This is just a chain reaction. Chain reaction means something happened to the covalent bonding. The 2 double bond will break into 1, so they will join together. Okay. So same, this one also same microstructure. So you have linear, branch, cross ring means they join the top and the bottom. They join as a cross ring, and then network. Network is a 3-dimensional structure. Okay. So this is on the molecular structure. Molecular structure, if you see a straight line, is a linear. If you see there's a branch, then it's called branch. Then you see there's a linkage between the branch or linkage between the linear, then it's a cross link. If you see there's a three-dimensional linkage, then it's called network. Okay, we do a little bit exercise on calculation. So you're given PVA. So you'll see PVA monomer on your question. So you'll see A is a polyvinyl acetate, B is a polyvinyl chloride. So you're given the monomer here. So here, you know that when you see molecular structure, the first step is to calculate the molecular weight of that monomer. So you start to count like how many carbon, how many hydrogen, how many oxygen, right? How many chlorine, Cl. So all this you can find in the periodic table. So carbon is 12, H is 1, oxygen is 16, Cl just now is, I forget it, Cl just now, 35, okay, like that. So you calculate each one of it. So it asks you to molar fraction of each component. So we need to find like how many percentage of H inside this one. How many O oxygen inside this structure. So again, if you see mole fracture means you need to calculate something divided by the total amount of that thing, right? So in here, you can use 1 kilogram, you can use 100 gram. In this example, I use 100 gram, right? So some of you, if you see it's a very large number, then normally we'll use 1 kilogram, right? But here we just use 100 gram. So in 100 gram, so here, if you have a copolymer consists of 15% of PVA and 85% of PVC, so you add these two, you get 100%. So just to make calculation to become very simplified, you just use 100 grams. So in 100 gram, you have 50 gram of PVC, 85 gram of PVC, right? PVA and PVC. Makes sense, right? Just simplify the question with 100 gram. Okay, then we will determine each mole for each component, like how many mole here, how many mole here. Then you calculate individual fraction. So we start with the first one, this one, polyvinyl acetate PVA. So you calculate how many carbon you have, how many hydrogen you have, how many oxygen you have. So here you have 4, you have 6, you have 2 oxygen, right? If you count 3 carbon, 2 oxygen, 1, 2, 3, 6, 6 hydrogen, and so on. So you calculate, you get 86 for PVA. And its in unit is gram per mole, gram per mole. For engineering subject, normally the unit will carry 50% of the marks. For example, the full mark for this 86 gram per mole is 2 marks. If you only write 86, you only score 1 point. So once you find, then you find in how many moles in PVA in 100 gram of copolymer. You just take 50 gram because you only have 50 gram. Then you take acetate PVA, 86, 15 divided by 86. You get 0.174 mole. Okay. This is a fraction of mole. So if you do the same for PVC, you do the same. So you have 2 carbon, 3 hydrogen, 1 chlorine. Chlorine is 35.5. Okay, so you get 62.5. So you calculate the same mole in 100 grams of copolymer. Right? So you get 80, sorry, yeah. I think something wrong with my numbers here, right? It should be, wait, is it 85? It should be 85 over here, 62.5 here. I flipped the typo error because if you follow the front one, the below is the most of that things.